You must have seen coal and petroleum being used as fuels. Did you know, however, that both coal and petroleum are hydrocarbons? They are in fact referred to as fossil fuels. Hydrocarbons found within the top layer of the Earth's crust and used as fuels are called fossil fuels. Petroleum is formed from the preserved remains of organisms that settled at the bottom of seas. Over time, this organic matter mixed with mud and got buried under heavy layers of sediments. This resulting heat and pressure caused the organic matter to change chemically. Coal is formed in the same way when dead plants and animals on Earth get impacted by heat and pressure. In this lesson, you will learn more about the chemical properties of carbon compounds, like coal and petroleum, and the type of reactions they undergo. All carbon compounds react with oxygen to produce heat and light, along with carbon dioxide and water. This reaction of carbon with oxygen is called combustion. For example, when methane burns in air, it gives carbon dioxide, water, heat, and light. Similarly, ethyl alcohol gives carbon dioxide, water, heat, and light when it undergoes combustion. Aliphatic compounds on combustion produce a non-sooty flame, and aromatic compounds on combustion produce a sooty flame. Let's try to prove this through an experiment. Take a small amount of naphthalene on a spatula and burn it. While burning, place a metal plate above the flame. Repeat this process using small quantities of camphor and alcohol. You will find that naphthalene and camphor burn with a yellow flame and give out soot, while alcohol burns with a blue flame and does not give out soot. Naphthalene and camphor are aromatic compounds, while alcohol is an aliphatic compound. Thus, we can conclude that aromatic compounds produce a sooty flame when burnt, and aliphatic compounds burn with a non-sooty flame. The process of combustion can be classified as complete and incomplete combustion. Let's try to understand this concept better through an experiment. Take a Bunsen burner and light it, keeping the air hole completely open. You will see that the gas in the burner burns with a blue or non-sooty flame. Now, gradually start reducing the size of the air hole. As a result, the amount of air going into the burner will keep decreasing. As the amount of air decreases, the gas in the burner burns with a sooty flame and produces black smoke. This is because there is insufficient oxygen available for complete combustion. So we can conclude that saturated compounds on incomplete combustion produce a sooty flame. This is why the bottoms of pots and pans get blackened by the flame from domestic gas burners when the air holes have not been cleaned for some time. Carbon compounds undergo oxidation reactions. For example, alcohols undergo oxidation reactions and form carboxylic acids and water. Let us learn more about oxidation of alcohols through an experiment. Take a small amount of ethanol in a test tube and place it in a water bath. Now, add a 5% aqueous solution of alkaline potassium permanganate, drop by drop, to the test tube. The purple color of potassium permanganate disappears due to the oxidation of ethyl alcohol to acetic acid. Continue adding potassium permanganate till the purple color of potassium permanganate no longer disappears. This shows that the oxidation of alcohol to acid is complete. The ethyl alcohol solution is oxidized to ethanoic acid in the presence of alkaline potassium permanganate solution. Ethyl alcohol is oxidized to ethanoic acid in the presence of potassium permanganate. Since potassium permanganate provides the oxygen in the reaction, it is an oxidizing agent. Another example of an oxidizing agent is potassium dichromate. Carbon compounds undergo a reaction known as addition. Addition reaction is one in which a molecule adds across a double bond or a triple bond. Hydrogenation is a chemical reaction that results in addition of hydrogen. In this addition reaction, hydrogen is added to unsaturated hydrocarbons in the presence of a catalyst to produce saturated hydrocarbons. A catalyst is a substance that helps in a reaction without itself undergoing any change. The most common catalyst used during the process of hydrogenation is nickel. A common application of hydrogenation is in the food industry. Vegetable oils that are unsaturated hydrocarbons are converted to saturated oils by the process of hydrogenation. However, in general, the process is not carried out to completion. This partially hydrogenated oil contains some amount of trans fats which are unsaturated and may lead to heart diseases. A substitution reaction is a chemical reaction in which an atom or a group of atoms replaces another atom or a group of atoms in a molecule or ion. Saturated hydrocarbons, being unreactive normally, undergo substitution reactions. The hydrogen atoms of the hydrocarbon get replaced by atoms of other elements. When equimolar amounts of methane and chlorine react in the presence of sunlight, then a mixture of chloromethane, dichloromethane, chloroform, and carbon tetrachloride is formed. In this reaction, chlorine substitutes the hydrogen atoms one by one. Initially, chlorine replaces or substitutes one of the hydrogen atoms and forms methyl chloride or chloromethane. Chloromethane reacts with chlorine to form dichloromethane. Dichloromethane reacts with chlorine to form chloroform. Chloroform, on further chlorination, forms carbon tetrachloride.